So in this problem, we are being provided with the equation of three lines. We need to verify that these three lines are concurrent. Okay, let us begin. So we know that three lines are going to be concurrent if we can form a 3 by 3 determinant using the coefficient of x and y, including the constant term, and equate it to 0. So that means let's start with the 3 by 3 determinant. Now in the first column, we're going to consider the coefficient of x, which is b plus c. Then in the first row, second column, we're going to take the coefficient of y, so that is 1. And in the first row, third column, we're going to consider the constant term, which is 1. Then similarly, in the second row, we're going to take the second equation of the line. So in the second row, first column, we have the coefficient of x, so that's c plus a. Then we have coefficient of y, which is b. So let's place it in the second row, second column, and then we have 1 placed in the second row, third column. And then finally in the third row, we have a plus b, c, and 1. So if these three lines are to be concurrent, then this determinant value must be equals to 0. So let's check whether if it is true or not. So what we'll do, we're going to expand this determinant along the first row. So here we have the first element in the first row, first column, that's b plus c. So that's going to get multiplied to a 2 by 2 determinant, which can be obtained by neglecting all the elements in the row and all the elements in the column that contains b plus c. So we are left with b1, c, and 1. Minus, we take the next element in the row, so that's -1. That's also going to get multiplied to another 2 by 2 determinant. The rules remain the same. We are going to reject the row and the column that contains the element a. We are left with c plus a, 1. And we have a plus b, 1. And then finally, we have the third term. This is going to be the element in the first row, third column. 1 gets multiplied to the another 2 by 2 determinant, where we have the elements c plus a, b, and then we have a plus b and c. Now let's further simplify. So we have b plus c. So that gets multiplied to, so b times 1, that's b, minus c times 1, that's c, minus we have a multiplied to, so c plus a times 1, that's c plus a, minus a plus b times 1, that's negative a, negative b, added to 1 multiplied to, so c plus a times c, so that's c squared plus ac, minus b times a plus b makes it ab minus b squared. Okay, let us further simplify. So we have b squared minus c squared, minus, so here positive a and negative a gets cancelled out. So negative a multiplied to c makes it negative ac. Negative a times negative b, so that's positive ab. Plus we have c squared plus ac minus ab minus b squared. As we can see here, all the terms are getting cancelled out, leaving us with 0. So here we have successfully verified that since the determinant is 0, it must be true that these three lines has to be concurrent. That means they are going to have a common intersection point.